Welcome to this module. In this module what we will see how can we deposit a gold pad over the piezoresistive material. So, if you see the slide until the last module what we have seen how can we deposit piezoresistive material on interdigital electrodes which are fabricated on a silicon dioxide insulator below which there is a micro heater. So, let me teach you today how can we have this gold pad on the piezoresistive material, but before that if you have a piezoresistive material. So, I will draw it here the wafer right with a piezoresistive material and a heater and an interdigital electrodes. Now, you should also know quickly when you want to draw it is silicon dioxide. It is always good to repeat whenever we draw the process flow. So, it becomes kind of a repetitive way of training your brain. Okay. If you understand the artificial intelligence and machine learning, you will see that the iterations, number of time the system is trained, the better the accuracy, and then when you go for testing you will understand that your system shows a way better accuracy if you have the samples which you can train it for long time. So, my point is whenever I am drawing a schematic I always try to speak, but you should also try to understand and speak along with the slides. It becomes easier and you are training your brain faster. Okay. So, this is a nichrome, is a heater, silicon dioxide with which technique, PECVD, silicon dioxide which technique, thermal oxidation, silicon wafer is there, and then this is nichrome using PVD, and then we have pattern using photolithography. Over that you have interdigital electrodes right like this which is made up of chrome gold, right, made up of chrome gold. Let us design here like this, and then over this what you have piezoresistive material. Now, next step is we have to deposit a gold pad on this piezoresistive material, but if I deposit gold pad directly on the piezoresistive material it will be shorted. So, what will I do? I will first deposit or grow silicon dioxide on this piezoresistive material. So, in fact, let me change the color so that it becomes little bit easier. I will have a silicon dioxide layer on the piezoresistive material. This silicon dioxide is deposited using PECVD, right, because I want to have an insulating layer, between the gold pad and the piezoresistive material. What is this material? Piezoresistive material. What is this? Chrome gold. Chrome gold is pattern in which design? What is the design of the chrome gold? Interdigitated electrodes. Okay, easy. Now, PECVD. So, PECVD, so that means we have silicon dioxide. Now, what we have to do? We have to open the silicon dioxide, or we have to open the contact which is this region and this region, and we have to protect the remaining region, right. For that what can I do? I have to do a lithography. So, I will go for a lithography technique in which we will spin coat positive photoresist and after spin coating positive photoresist we will go for soft bake 90° 1 minute hot plate, right. On that we will load the mask. Now, what I want to do? I want to open only this region and remaining region I want to protect my silicon dioxide. So, if I want to open this region and remaining region if I want to protect it, then I have to go for a dark field mask. I have to go for a dark field mask. This is my dark field mask. After dark field mask, I will expose the wafer with UV light. I will expose the wafer with UV light. Okay. After this, what will happen? That when I dip this wafer in a photoresist developer, if I dip this wafer in a photoresist developer, the photoresist, so I will just show it right down here, the photoresist will be there in all the region except the contact area, because the unexposed region in case of the positive photoresist will be stronger, right. So, I will have photoresist in this area. Now, what is my goal? My goal is to remove silicon dioxide from the contact of the interdigitated electrodes and a heater electrodes or heater contacts, right. So, the next step after this would be to do the hard bake. Let's see, if even if I miss, it is assumed that whenever you use photoresist, you have to do soft bake, you have to do hard bake. Okay. However, I will try not to miss, so do not worry. So, after this we perform hard baking, and after hard baking our next step would be to dip the wafer in buffer hydrofluoric acid. If I dip the wafer in buffer hydrofluoric acid, then what will happen? I will have silicon dioxide protected only in the region which is protected by photoresist. I will have silicon dioxide left only in the region which was protected by my positive photoresist. Okay. Next step is we have to strip off the photoresist. So, what will I do? I will then dip the wafer in acetone. So, once I dip the wafer in acetone, what will happen? My positive photoresist will strip off. My positive photoresist is strip off. Now, over this I want gold pad, over this I want to pattern a gold pad. So, what will I do? I will just remove these things. So, I hope that until here it is easy for you, that we have deposited a silicon dioxide using PECVD, and then we have patterned it such that we can get silicon dioxide on all the region except the contact region. The next step is to deposit gold pad only in this region, right, and contacts in this region, because it will improve the thickness of the contact layer, and if the thickness of the contact layer increases or it the thickness is more, the better. If you understand what are the ohmic contact and rectifying contact, you will understand why the thickness of the metal is important or is related to the contact. Now, over this, because we want a gold pad, we will deposit gold using PVD, physical vapor deposition. When I say gold, it is assumed that there is a thin layer of chrome below gold, right. After this, the next step would be that I will deposit a photoresist, which is my positive photoresist, and then over the photoresist, after positive photoresist, spin coat. I will not deposit, I will spin coat the photoresist, and after spin coating photoresist, I will go for soft lithography. Is it correct word? No, it is not correct word, it is not soft lithography, it is soft bake, right. After spin coating my positive photoresist, I will go for soft bake, and when I go for soft bake, I will then follow with loading the mask, and my mask is such that it will protect, because it is a positive photoresist. I want to have a bright field mask which will protect the region in the way I am showing you right now. So, the region which is dark here, right, because there is a positive photoresist, this region will not expose the wafer with UV. So, if I use UV here for exposing the wafer, you can see that the dark area will not be exposed and the gold below the dark area will be protected. So, if I use UV light to expose the wafer and then I perform a photoresist developer, then what will I have? I will have my photoresist only in this area, and this area. This is my positive photoresist, right. After that I have to go for hard bake. Hard bake is done at 120 1 minute hot plate. After that, next step is you have to dip the wafer in chrome etchant followed by gold etchant. Chrome etchant followed by gold etchant. When you do that, what you will have? When you dip the wafer in a chrome etchant followed by gold etchant, what you will have is this pattern, right. And then the next step is to strip off the photoresist. So, I will dip the wafer in acetone. When I dip the wafer in acetone, my positive photoresist will be stripped off. Thus, I have a gold pad on interdigitated electrode which has a piezoresistive material. You got it? Easy, it is very easy, right. So, when I have this, then I will get my this design without SU8 pillars. These 4 dots that you can see are SU8 pillars over gold pad, right. So, if I follow this schematic, what we have seen? We have taken a silicon wafer, this is oxidized silicon substrate, this is a nichrome, we have an insulator, we open the contact of the insulator and fabricate interdigital electrodes. Over that we have piezoresistive material, then we have insulator, we open the contact like this contacts, this one, right, 8 of those, this one, and then we deposit a gold and pattern it. So, we are on step number 7 right now. The next time in the next module, what I will teach? I will teach how can you fabricate the SU8 pillars which are right over here, and followed by how can you make those pillars conductive. When you do that, you have to go for one more process where you have to create a diaphragm, and that will be the end of how to design a biochip, MEMS based biochip, which will consist of a micro heater, interdigital electrodes, piezoresistive material, electrical sensors, right, and a diaphragm. And then we will see why we have taken so much pain to understand this particular design, and how can we use this design to understand the change in the tissue property as cancer progresses, right. Till then you go through this lecture and I will see you in the next module.